Hello everyone, welcome to Applied Chemistry Tutorials. So today we are going to discuss about mean deviation, variance and standard deviation of group data. So let's start with a brief introduction. In our previous videos, we have already discussed about central tendency and dispersion in details. So central tendency is where data points are centered in a given data set, and dispersion is how these data are scattered. So to know this in details, please check the link shown here. So in this video, we are going to discuss about dispersion mostly, and as I have mentioned, we have already discussed different ways to measure the dispersion for ungrouped data: range, mean deviation, variance and standard deviation. And in this video, we are going to do the same for group data. So similar to that of the ungrouped data, there are four major ways to measure the dispersion for group data, such as range, mean deviation, variance and standard deviation. So we are going to discuss all this in this lecture. So let's talk about the problem statement. So let us consider there are 15 students in a chemistry class obtain the following marks out of 100. So the marks obtained or xi are shown in row 1, and the number of students or frequencies fi are shown in row 2. So we have the same problem as we have discussed in our video, mean, median and mode for group data for ease of understanding. So this type of data is known as discrete frequency distribution. Similarly, we can convert this into another format which is known as continuous frequency distribution. Here, instead of marks obtained xi term, we are having class interval. So you can see there are different class intervals here: 40 to 50, 50 to 60, 60 to 70, and it represents how many students will fall into this particular class interval. So here the student who got 42 will fall in 40 to 50 class interval. Who got 53 will be in the 50 to 60 class interval. Similarly, who got 60, two students got 60 and one got 63. So this 2 plus 1 or 3 students will fall into 60 to 70 class intervals. So to know details and the rules about this discrete frequency distribution and continuous frequency distribution, you can check our videos on mean, median, mode for group data. So in this problem, we need to find out the range, mean deviation, variance and standard deviation for group data. So let's start with range. So the marks obtained at xi are mentioned in row 1, and the number of students or fi are shown in row 2 for discrete frequency distribution here. And clearly we are having range equals to maximum value minus minimum value, which is equals to 97 minus 42 or 55. Similarly, for continuous frequency distribution, we are having a similar tabular format where instead of marks obtained, we are having a class interval. So clearly, we do not have the maximum values or minimum values mentioned here in this table. So we cannot directly measure the range from this type of tabular format. So it is to be noted that determination of range is easy and it can give us some idea of variability, but it will not tell us about the dispersion from a central tendency. And to know the dispersion from a central tendency, we can calculate mean deviation about a central tendency. Say x1, x2, x3 up to xn are the values or class marks for n quantities, and f1, f2, f3 up to fn are their frequencies. So we need to find out the mean deviation from a central tendency A, and for that we need to follow the steps. Step 1, the mean deviation is to be measured about a central tendency A. So the first thing we need to do is to find out the value of that central tendency or A. It can be median, it can be mode, it can be mean. And in step 2 we need to find out the absolute values of all the deviation, that is we have x1 and we figure out A, so x1 minus A and mod of that. So similarly we have mod of x2 minus A, mod of x3 minus A up to mod of xn minus A. And in step 3 we need to find out the mean of absolute values of all the deviation, that is the mean deviation about a central tendency MDA can be given as summation of fi multiplied by mod of xi minus A from I equals to 1 to n divided by summation of fi from I equals to 1 to n, where A can be any central tendency. So let's talk about mean deviation about mean for discrete frequency distribution, and in future we are going to talk about mean deviation about median for continuous frequency distribution, so that we have all the ideas. So for discrete frequency distribution we have marks obtained or xi shown in row 1 and the number of students fi shown in row 2. So to calculate the mean x bar we can use the formula shown here. So x bar equals to summation of fi xi from I equals to 1 to n divided by summation of fi from I equals to 1 to n. So this fi xi term can be calculated from the given table that we obtained from our problem statement. So fi xi is the fi term multiplied by corresponding xi term. So 1 multiplied by 42 equals to 42 here, 1 multiplied by 53 53, 2 multiplied by 60 is 120, and so on. So once we have our fi xi terms, we can add them up in the numerator, and similarly when we have our fi terms we can add them up in the denominator. So when we put all the numbers in, we can have our x bar term is equals to 73.9. So when we figured out what should be our x bar or mean, then we can focus on to the bottom part of the table. Here xi minus x bar can be determined next. So xi for particular column we have 42 here and minus the x bar term we calculated here. So 42 minus 73.9 is minus 31.9. 53 minus 73.9 equals to minus 20.9, and so on. And after calculating all these terms we can take the absolute values of xi minus x bar. So all the negative values will be turning into the positive values, and the positive values will remain as positive values here. So minus 31.9 will be 31.9, minus 20.9 will be 20.9, and so on. Finally we need to calculate fi mod xi minus x bar term. So we can calculate this by multiplying fi and then with corresponding xi minus x bar mod term. So here 1 multiplied by 31.9 is 31.9. Similarly for this column we are having 1 multiplied by 20.9 or 20.9. So we got all the values that we are looking for here. So in continuation with our previous slides, we have our xi term in row 1, fi term in row 2, and the fi mod xi minus x bar term that we just calculated in last slide here in third row. So the mean deviation about mean can be calculated by using the following formula. So md x bar equals to summation of fi mod xi minus x bar from I equals to 1 to n divided by summation of fi from I equals to 1 to n. So we have all these terms here mentioned in the third row, and we can add them up and put them into the numerator. And similarly we have all the fi terms here in the second row, and we can add them up and put them into the denominator. So md x bar is equals to 11.4, as we can calculate by putting all the numbers in. So we can say the mean deviation about mean for discrete frequency distribution is 11.4. Now, before going into the calculation of mean deviation about median for continuous frequency distribution, first we need to calculate the median. So, for median, we have the following tabular format. The class intervals shown in row 1, number of students are defined in row 2, and now from this we can calculate the cumulative frequency or FCI term. So, we have discussed this in details in our videos about on mean, median and mode for group data. Just a quick recap, we having cumulative frequency for the first term is equals to the frequency, which is 1. Then for second term we are having 1 plus 1 equals to 2. Then for 60 to 70 interval we have 2 plus 3 equals to 5, and so on. So to find out the median, the first thing we need to do is find out n by 2, where n is the number of observations, which is 15. So n by 2 is 7.5. And now we need to figure out the nearest and greater integer than that of 7.5, which is absolutely we can have it as 8 here. And now we need to figure out which should be the 8th term. So as we have discussed in details, so we can have the first term will fall into the 40 to 50 category, the second term in 50 to 60 class interval, the third, fourth and fifth term will be in 60 to 70 class interval, and the sixth and seventh term will be in 70 to 18 class interval, and the 8th, 9th, 10th, 11th and 12th term will be in 80 to 90 class interval, and 13, 14 and 15 term will be in 90 to 100 class interval. So definitely the 8th term will fall into this 80 to 90 class interval category. So we now have our median class 80 to 90. So median now can be determined after finding the median class. So median is equals to L plus n by 2 minus fc divided by f whole multiplied by h, where L is the lower limit of the median class, which is 80, n is the number of observation, which is 15, fc is the cumulative frequency of the class preceding the median class, which is 7, f is the frequency of the median class, which is 5, and h is the size of the class interval, which is 90 minus 80 or 10. So after putting all the values in, we can have our median is equals to 81. So median, or we can say it a capital M, equals to 81 here. Now once we have our median value, so we can easily calculate the mean deviation about median for continuous frequency distribution. So let's focus on the top part of the table first. So we are having the class intervals here in row 1, and from this we can easily calculate the class marks or xi term, which is equal to the upper class limit plus lower class limit divided by 2, or 50 plus 40 by 2 or equals to 45 here. Similarly for 50 to 60 we are having 60 plus 50 by 2 or 55 here, and so on. And number of students are shown in the third row. Now as we are having m equals to 81, so to calculate xi minus capital M, we can easily find out the xi term is 45 here for 40 to 50 class interval, minus the median is 81, so we are having minus 36. Similarly for 50 to 60 class interval we are having 55 minus 81 equals to minus 26, and so on. So when we are taking the absolute values for xi minus capital M, so the negative terms will turn into the positive terms, and positive terms will remain as positive terms. So minus 36 will become 36, minus 26 become 26, and so on. And 4 remains as 4, 14 remains as 14. So finally we need to calculate fi multiplied by modulus of xi minus capital M term. So we are having the fi term for a particular class interval. Here for 40 to 50 it's 1, multiplied by modulus of xi minus capital M, where it is 36 here. So we are having 1 multiplied by 36 is 36. Similarly for 50 to 60 we are having 1 multiplied by 26 equals to 26, and so on. So in continuation with the last slide, we are having our class intervals in row 1, the class marks in row 2, the number of students are in row 3, and fi multiplied by mod xi minus capital M term in row 4. So the mean deviation about median can be calculated as summation of fi multiplied by mod of xi minus capital M from I equals to 1 to n divided by summation of fi from I equals to 1 to n. So we are having all fi multiplied by mod xi minus capital M term here, and we are also having all the fi terms here. So we can add the fi multiplied by mod of xi minus m terms. We can add all these terms and put them into the numerator, and similarly we can add all the fi terms and put them into the denominator as shown here. So after calculation we are having mean deviation about median is equals to 12.3. So therefore we can say the mean deviation about median for continuous frequency distribution is 12.3. Now let's move into variance and standard deviation. So mean deviation from central tendency can sometimes lead into erroneous results. I am not going into details for this, and to avoid these issues, variance or sigma squared term can be a way to represent the dispersion, which can be given as sigma square equals to summation of fi multiplied by xi minus x bar whole square from I equals to 1 to n divided by summation of fi from I equals to 1 to n. So this equation is valid for both discrete frequency distribution and continuous frequency distribution. Now similarly we can determine standard deviation of sigma using the following formula. So sigma is square root of sigma square or variance, so which is equals to a square root of summation of fi multiplied by xi minus x bar whole square from I equals to 1 to n divided by summation of fi from I equals to 1 to n. So this equation is also valid for both discrete frequency distribution and continuous frequency distribution. So let us calculate the variance for discrete frequency distribution for the given problem. So we have the marks obtained xi terms in row 1 and the number of students or fi term in row 2. And so first we need to calculate the x bar or mean from this given data. So let's focus on the top part of the table now. So we are having x bar equals to summation of fi xi from I equals to 1 to n divided by summation of fi from I equals to 1 to n. So fi xi term now can be calculated easily here, multiplying fi and corresponding xi term. So 1 multiplied by 42 equals to 42, 1 multiplied by 53 equals to 53, and so on. So we can add all these fi xi terms here, and then we are having all the fi terms here. We can all add all the fi terms here. So now our x bar, as I mentioned, we can calculate by adding all these terms. So fi xi terms will be added in the numerator and the fi terms will be added in the denominator. So it gives us x bar equals to 73.9. Now when we have our x bar value, now let's focus on the bottom part of the table. So we can easily calculate xi minus x bar term. So xi for a given column we are having here 42 minus x bar is constant for all these columns, which is 73.9. So 42 minus 73.9 or minus 31.9. Similarly for this column we are having 53 minus 73.9 equals to minus 20.9, and so on. Next we need to find out the square term of this xi minus x bar. So xi minus x bar whole square is equals to minus 31.9 whole square or 1017.6, and similarly we can calculate this for all the given columns here. And finally we need to figure out fi multiplied by xi minus x bar whole square term, so which is equals to 1 multiplied by 1017.6 equals to 1017.6 for column 1 here, and here we can have 1 multiplied by 436.8 equals to 436.8 for the students who got 53 here or this particular column. And similarly we can calculate all the fi multiplied by xi minus x bar whole square term. So after calculating all these terms we can put them into the table. So marks obtained are xi are shown in row 1, fi in row 2, and all fi multiplied by xi minus x bar whole square term in row 3. So the variance of sigma square can be given as summation of fi multiplied by xi minus x bar whole square I equals to 1 to n divided by summation of fi from I equals to 1 to n. So we can have our all fi multiplied by xi minus x bar whole square terms here. We can add them up into the numerator, and also we are having all the fi terms here, and we can add them up and put them into the denominator. So after adding, we are having the values here as 3450.8, and we are having all the summation of fi terms is equals to 15. So we can have a sigma square value 230.1. So therefore the variance for discrete frequency distribution is 230.1. Similarly, we can calculate the variance for continuous frequency distribution. So let's focus on the top part of the table here for the continuous frequency distribution. So we already have shown the class intervals from the problem statement. We calculated about the class marks here, and we shown it before into the row 2 and the number of students fi in the row 3. So we can easily have our value fi xi from the table here. So x bar or mean can be calculated similarly from the given equation. So fi xi term can be calculated here. So fi multiplied by corresponding xi, so 1 multiplied 45 equals to 45, 1 multiplied by 55 equals to 55, and so on. So we can add all this fi xi term together into the numerator, and we can add all the fi terms here into the denominator, and as shown here. So we can have our value of x bar equals to 77. So now as we have our value of x bar, we can now focus into the bottom part of the table where we can calculate xi minus x bar here. So x bar is constant for all these class intervals, so which is 77. Now for this particular column, we are having xi is 45 minus x bar is 77 equals to minus 32. Similarly, for 50 to 60 class interval, we are having xi minus x bar equals to 55 minus 77 equals to minus 22, and so on. Now we are taking the square terms of this. So minus 32 square is equals to 1024, minus 22 square is 484, and so on. And finally we are calculating fi multiplied by xi minus x bar whole square. So here fi is 1, and the corresponding xi minus x bar whole square term is 1024, so equals to 1024 here. And similarly we can calculate all the fi multiplied by xi minus x bar whole square term for all the class interval as shown here. So now as we have all the value in tabulated format, so we can put them in a concise table here. So we are having class intervals in row 1, class marks in row 2, number of students fi in row 3, and fi multiplied by xi minus x bar whole square in row 4 here. So sigma square or variance can be given as summation of fi multiplied by xi minus x bar whole square from I equals to 1 to n divided by summation of fi from I equals to 1 to n. So we are having all the fi multiplied by xi minus x bar whole square term here, and we can add them into the numerator, and similarly we are having all the fi terms here, we can add them into the denominator. So we are having all these terms added together as 3240, and we are adding all the fi terms together, and which is equals to 15. So we are having our variance 216. So we can say the variance for continuous frequency distribution is 216. Now let's talk about the standard deviation. So for discrete frequency distribution, we are having sigma equals to square root of variance, as we have mentioned already. So if we have already the variance data, so we can just put the numbers for variance. So here we calculated the sigma square for discrete frequency distribution is 230.1. So sigma is square root of 230.1, which is equals to 15.2. And so we can say the standard deviation for discrete frequency distribution is 15.2. If we don't have the variance data, we can just do the calculation from the scratch as we have shown it for the variance calculation. And similarly, for continuous frequency distribution, we can use the similar formula here, and we already have the variance or sigma square value, which is 216. So sigma is square root of variance, or square root of 216 gives us 14.7. So we can say the standard deviation for continuous frequency distribution is 14.7. So that's all for today, and that concludes our lecture series on central tendency and dispersion for grouped and ungrouped data. And please stay tuned with our channel for more videos. Thank you.